So as I said, my name is Adrian Fernandez, and I manage our TI microcontroller development portfolio. So we have a whole bunch of development kits that we offer engineers, specifically IoT, to help them get up and running very quickly with prototypes and then ultimately get to production. And what I will start off with here today is a demo. The PowerPoint, we can get to that, but really the main thing I wanted to showcase here is, again, that sort of interaction that we have with various cloud services. But the first place I'll take you here is ti.com/launchpad, or I'm sorry, ti.com/IoT. So this is a portal page that you guys can go ahead and visit and see the various cloud services that we support. If you click on the Cloud Solutions tab, scrolling down here, you'll see some of the partners that we work with. So as I mentioned, over 25 different cloud partners that we work with, from the big guys all the way down to some of the smaller ones. So you see some familiar names like AWS, IBM, Bluemix, Microsoft Azure, so on and so forth. But we're also working with some of the smaller ones as well. The demo that I'll be running through today is actually with a company called Tembu. Has anyone heard of Tembu here? Okay, cool. Well, I'm actually excited that no one raised their hand, because I think what you'll see, you'll be pretty blown away. I think you'll be really excited about some of the integration that we have with that particular cloud partner. But what's cool about this is that this isn't just a marketing page. This is the resource page for your developers. All of these links here are clickable. You just simply click on any of these, and they will take you to a tutorial, some documentation, some training in terms of how to get TI hardware working with that specific cloud service. So in this case, this is PubNub, a pub-sub kind of a communication protocol, and we have support for them as well. But again, in this particular instance, the demo that I'll be showcasing is with a company called Tembu. So let's go ahead and take a look at what Tembu does. I'm going to go ahead and click on their page here. And Tembu, what they are, they're an API aggregator. So you guys are familiar with RESTful APIs, right? Websites expose services, APIs to each other to exchange data. It's this sort of API economy. ESPN can exchange data with weather.com, who can exchange data with Facebook, so on and so forth. And that's just the way the internet has interacted with each other for eons, right? But now that I have microcontroller development boards, I have one here. This one here is the TI Launchpad kit. If you can't see it, it looks like every other hardware. You've probably seen several of them here today. But it's a TI microcontroller right there in the middle. And this does have an integrated Wi-Fi chip. We have single chip solutions, which is an ARM M4F with Wi-Fi built into the same chip. So with a single chip, you have a reprogrammable microcontroller and Wi-Fi integrated. And now that I have little tiny 32-bit ARM MCUs that can interact with the cloud, I can talk the same REST APIs that the internet and web services and websites have already been using. I can tap into that and make my embedded applications more intelligent. And that's what Tembu helps us do here. So I'm going to go ahead and I already have my account set up. You guys can do everything that I'm about to do here today. And I'm just going to go ahead and click on the Tembu logo here. And here on the left are all the cloud services that Tembu has support for. These are all websites, services, etc., that have a RESTful API that they expose externally. And if I wanted my little tiny microcontroller board to blink an LED when my package arrives from FedEx, the sort of quote-unquote old-fashioned way would be me having to get up and running with a SDK. I need to learn about how to do my HTTP client library with my microcontroller. I then have to go to FedEx.com, create a developer account, read their API documentation, and then implement that on my own. But what we've done is with our SDK, we provided these APIs to these various cloud services, and Tembu is actually going to generate code on top of our SDK to enable your microcontroller device to interact through that RESTful API. And I'll show you what I mean by that. So as an example, we said FedEx, right? We buy stuff from Amazon Prime all the time. I want to blink the green LED when my package arrives at my front porch. I go here to FedEx, tracking and visibility, track by number. And here we have tight integration of our TI hardware with this particular cloud service. So I just say, hey, Tembu, I'm using my TI Wi-Fi chip, the CC3100. I'm connected in this way, and this is where I can put in my SSID and my password, my Wi-Fi credentials. So let's go ahead and put that in. These are just placeholders for now. Hit save. And now Tembu knows how my hardware can connect to the cloud. I provided it with my sort of home Wi-Fi credentials. And then here is where I can put in my FedEx information. I just provide my FedEx account number, my FedEx authentication key, and then ultimately my FedEx tracking number. And with those three pieces of information, Tembu has everything they need to generate the code on top of my Wi-Fi SDK to enable my Wi-Fi-enabled microcontroller development board to talk to the FedEx server. And you can actually scroll down here, and you see the complete code here. So this isn't just a code snippet. This is a complete project file that I can hit copy and paste into my IDE of choice. We have Arduino-based IDEs. We also have full-blown IDEs as well, Code Composer Studio, which is our Eclipse-based IDE. We just recently announced a cloud-based IDE as well, so you can actually do your cloud development with a cloud-based development environment called CCS Cloud. But in this case, I'm just going to go ahead and use Energia. So I'm just going to go ahead and paste that code that we generated and program my board. And I already programmed it, so it's a little bit like a cooking show, just to save you from the compile time. But I've already programmed this particular board, so I'm going to go ahead and plug it in over my serial port so you can see what my Launchpad's trying to do now. So bear with me. I switched laptop.
Test, yeah.
Test, okay, cool. All right, so like I said, I already programmed this particular board with the code that we generated. And what this particular demo is doing, it's a little simple. What Tembu does is it generates the code to enable my Launchpad to ping the FedEx server every 30 seconds. And my Launchpad will receive a string that says delivered, pending, out for, delayed, whatever that response might be from the FedEx server. And now me as the innovator, the programmer, I can do whatever I want with that information I just extract from the cloud. I can add that simple if statement that says if status equals delivered, let's go ahead and turn that green LED on. So this kind of takes care of the sort of cloud hardware interface for you. And then you as the innovator, the application developer, can add whatever secret sauce you want around that. So that's pretty cool. The FedEx demo's a silly one. We have another one. Nexmo is another cloud service. I don't know if you've heard of these guys. They're similar to Twilio. They provide RESTful APIs for triggering SMS or voice calls. That's a very common use case for an embedded device, right? I might be deployed in the field. I might be reading a sensor. I trip a particular threshold. I want to call somebody. I want to let them know that, hey, there's something going on here. And Nexmo provides, again, RESTful APIs for doing that. And just like the FedEx example, I just choose the RESTful API I want to use, in this case, text-to-speech. Just like before, I provide it with a couple parameters like my Nexmo API key, my Nexmo API secret key, and then this is where I can type the message that I want to vocalize to the end user. So I can say, hey, Adrian, your house is flooding. Flooding. Good luck. Cool. And that string is going to be sent to the cloud using their RESTful API. My Launchpad is going to send it up to the cloud. The cloud is going to take that text and vocalize it, doing some text-to-speech. And then it's going to trigger that voice call and call my phone. And I simply have to provide my cell phone number here. Cool. And then again, it generates a code for me. In this case, it's going to call my phone every 30 seconds. So similar to the FedEx example. Every 30 seconds, runs that API, I get a phone call. 30 seconds later, I get a phone call. Not ideal. I don't want that. I only wanted to call my phone when a given I/O event happens, like maybe an analog sensor value exceeds a particular threshold. And Tembu's actually already done that as well. I just scroll down here and pick which pin I care about. I have an analog sensor pin hooked up to pin 6.1. And I just say, hey, there's a sensor hooked up to that. It's a, let's say, a liquid level switch. And I'll name it water and hit save. So now I can actually trigger that RESTful API to be called only if my moisture sensor is less than, greater than, or equal to the threshold I care about. So let's say it's 200. And then trigger just once a day. So I scroll down to my code, and what was previously calling my phone every 30 seconds now only calls my phone if sensor value is greater than 200. So it dynamically generated that code. Without writing a single line, I created more or less a fairly intelligent Wi-Fi connected moisture sensor that I can maybe put underneath my water heater, right? And my water heater overflows, I get notification, and I don't have to worry about a flooded garage, so on and so forth. In this case, it's a moisture sensor, but that could have been any sensor. It could be pressure, it could be temperature, it could be humidity, so on and so forth. And in this case, it's going to generate the code to help my Launchpad call my phone. So just like before, I hit copy, I paste it into my programming environment, and I'll be able to program my board. So I've got a Wi-Fi hotspot here that I need to turn on. That's why it says Wi-Fi failed. It's trying to connect to the hotspot that I set up earlier. So I'm going to go ahead and turn my hotspot on. Cool, and now it should connect here. Let's give it a second. Actually, I'm going to go ahead and reset. Oh, there we go. I'm going to reset the board so you can see what's going on here. So the first thing it does is it tries to connect to Wi-Fi. I provided my Wi-Fi credentials earlier, if you remember. So it knows exactly what my SSID and my password is. I turned on the hotspot on my phone. It's able to connect to Wi-Fi. It says, great, I'm connected. And now it's going to start pulling that sensor. As a stand-in for my moisture sensor, I have a little potentiometer knob here. I don't know if you can see it. And what I'm going to do is I'm going to slowly turn the knob, and we set the threshold to 200, right? So I shouldn't generate any phone calls until that threshold is met. And what I'm going to try to do, I'm going to put my phone on speakerphone so you can actually hear the message that was translated from text to speech in the cloud. So I'm going to make sure that I have speaker enabled and my phone is in max volume, and I'll hold it up to the microphone, and we'll see